a lesson on identifying and graphing parent functions. The first parent that we want to introduce you to is what we call a parabola, or a quadratic function. The equation looks like this: y equals x squared. So we're going to go ahead and substitute some numbers in for x into the domain. So I'm going to pick numbers like -2, -1, 0, 1, and 2. And we're going to substitute them in for x. So -2 squared equals 4. -1 squared equals 1. 0 squared equals 0. 1 squared equals 1. 2 squared equals 4. So we're going to go ahead and graph these ordered pairs. So on the x-axis, I'm just going to go by ones. So this represents 2, 4, 6, -2, -4, -6, 2, 4, 6, -2, -4, -6. All right, so let's go ahead and graph these ordered pairs. So the first ordered pair is we're going to go left 2 and up 4. The next one, we're going to go left 1 and up 1. The next one is 0, 0, which we also call our origin. And the next one is 1, 1. So we're going to go right 1 and up 1. And our last ordered pair is right 2, up 4. So you'll see the shape of this graph looks like a U. This is called a parabola or quadratic function. Now our domain. Our domain is what type of numbers can we plug in for x. There are no restrictions. So we say the domain is from -infinity to +infinity. Or another way to write this is all real, which represents all real numbers. Now the range. The range is your y value. So think about this as a horizontal line. Notice that down below here on the y's and the negative, it doesn't exist. It only exists from y equaling 0 to infinity. So you can write this a few different ways. Y is greater than or equal to 0, or as an interval notation, from 0 to +infinity. All right, let's move on to the next parent function. The next parent function is an absolute value. Its equation looks like this: y equals the absolute value of x. So we're going to go ahead and substitute the same numbers in as we did the previous example. So we're going to choose -2, -1, 0, 1, and 2. Now we're going to go ahead and substitute it in for x. So we say, what is the absolute value of 2? If you remember what an absolute value does, is when you take it out of the absolute value, everything becomes positive. The absolute value of -1 is +1. Absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 2 is 2. All right, so let's go ahead and graph these ordered pairs. I'm going to kind of stretch it out a little bit here. 1, 2, 3, 1, 2, 3, -1, -2, -3, -1, -2, -3. All right, let's graph these ordered pairs. So the first ordered pair is -2, 2. So we're going to go left 2 and up 2. The next ordered pair is -1, +1. So we're going to go left 1, up 1. The next ordered pair is 0, 0. Again at the origin. The next ordered pair is 1, 1. So right 1, up 1. The last ordered pair is 2, 2. Right 2, up 2. So what this is going to create is the shape of a V. This is your parent function for an absolute value. Now we're going to identify the domain and range again. It's very similar to the last example. The domain, any number can be plugged in for x. It exists forever. So I'm going to say -infinity to +infinity, or again, all reals. That's a short way to say all real numbers. Now the range is the same as the last problem. Notice that everything below this line, anything in the negatives doesn't exist. Anything above that line, the graph exists, from 0 to +infinity. So I'm going to write it y is greater than or equal to 0, or in interval notation, from 0 to +infinity for the y's. All right, so down to the square root. The square root equation looks like this. Y equals the square root of x. I'm going to choose the same numbers again for x. -2, -1, 0. But now I'm going to make it a little bit nicer. I'm going to choose 2 and 4, just so you can kind of see the difference. All right. Now I'm going to start with the positive numbers first. So the square root of 4. Square root of 4 is 2. Now let's go to square root of 2. Now go ahead and take out your calculators. I want you to know how to use your square root button. So go ahead and push the square root button and then put in 2. Notice that this is an approximation. So we're going to go ahead and just round it to 2 decimal places, 1.14. All right. Square root of 0 equals 0. Square root of -1. Now when you have that calculator, I want you to go ahead and plug that in. So take the square root of -1. What's going to pop up is some kind of message like doesn't exist, not a real number. So this doesn't exist. You can't take a negative square root. Same thing with this one, negative square root of 2. If you plug that in your calculator, it also won't exist. Let's go ahead and say doesn't exist. So we're going to be only graphing 3 ordered pairs. Now there are more ordered pairs that we could graph when we increase our x values, but we're going to stick with 3. So I'm going to say this is 0, 1, 2, 3, 4, 1, 2, 3, 4. All right, let's go ahead and graph it. The first order pair is 0, 0. The next one is over 2, up 1.4, and then over 4, up 2. Now the shape of this graph, I call it half of a parabola. It heads off to the right. All right, so now we're going to talk about the domain and range. The domain does not exist all real numbers. If you notice, this is your x-axis. Everything to the left of this doesn't exist. Everything to the right of this does exist. So you're only worrying about the positive x values. So we say our domain is x greater than or equal to 0, or from 0 to positive infinity. Now our range of values, I'm going to change colors here. Our range is our horizontal values. Notice that it does not exist below this line. It only exists above. So it has y greater than or equal to 0, or from 0 to positive infinity. Here's our last parent of this video, cubic. Y equals x cubed. So we're going to go ahead and plug some numbers in for x. So we'll choose -2, -1, 0, 1, and 2. So -2 times -2 times -2 is -8. -1 times -1 times -1 is -1. 0 times 0 times 0 is 0. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. All right, let's go ahead and graph this. I'm going by ones. All right. So we can graph it. The first order pair is -2, -8. So we're going to go left 2 and down 8. The next one, -1, -1. So we're going to go left 1 and down 1. Next order pair is 0, 0. Right at the origin. Next order pair is 1, 1. Right 1, up 1. Last order pair we're going to graph today, 2, 8. Right 2, up 8. So what we call the shape of this parent function is a snake. It rises on the right-hand side and it falls on the left. So notice our domain. Any number you can plug in for x. So -infinity to positive infinity, or all reals. And the same thing is true for the range. You get every number out on the y-axis. So again, -infinity to positive infinity, or all reals. So there are the first 4 parent functions for you to know.